Okay, now I need to discuss subtraction of mixed numbers. Subtraction of mixed numbers does require some borrowing, so this little section I wanted to do separately. So the first problem that we have here, 5 and 2/5 minus 3 and 2 and 3/5. I want to show first of all the stacking in the columns, so here we go. And the problem in this case is going to be that 2 minus 3 is not possible. That's where the borrowing is going to have to come in. And remember, subtraction order does matter. So I'm going to go over here to the 5. I'm going to borrow from that, and I'm going to make it 4. Now, we all know that we have to bring that 1 that I just borrowed over to the next place value down. Same thing as when we add or do subtraction in with whole numbers. So here, what I have to do, though, is I have to add that in. So I can do that in two different ways, and the most common way of it being shown is that I'm going to add in a fraction of 1. Any number over itself is a fraction of 1, so I'm going to add in 5/5 because my denominator is 5. And now I add these two up, so 2 plus 5, which is 7, and those are fifths, and so we have 7/5 that we are going to be able to subtract from. 7/5 minus 3/5, now I can subtract, and so that's going to give me 4 and fifths, and 4 minus 2, which is 2, and so now we have our answer. And that is the way that we borrow. And it's really not as difficult as you might think, you just need to practice it. There's one other way that we could show this. If we said it was 5 and 2/5, and we're borrowing from the 5 to make it 4, and we have the 2/5 over here, what we could do is we could say that we add a 1 in here. Now when we say that, we would want to make this sure that this 1 doesn't just get attached to the 2 and become 12 up here, because that's not true. What we need to make sure is that we see it as a mixed number. So 5 times 1 times 2, which is going to give us 7, and then that's over the denominator 5. So you see that this right here with that 1 coming over is going to be the exact same thing that happened up here when we added in the 5/5. In fact, that's all you're doing when you're changing to a mixed number. So that's what happens with borrowing. Now the next thing that we want to take a look at is what happens when we're adding or subtracting with a whole number and a fraction. When we add a whole number and a fraction, that's really just expanded form for a mixed number, and so it's really super easy. There's no work at all. We just take the plus out because this says 7 and 1/10, and we know that 7 and 1/10 can be re-expressed as just writing a mixed number. You saw that in a couple examples ago, and so that's our final answer. So adding a whole number and a fraction, super easy. Now when we go down to the subtraction one, this one is where we're going to have to do some borrowing again, but it's really easy because we don't have anything to add it to there. So 4 minus 1/5, we are going to borrow from the 4 and make it a 3, and then I'm going to take that 1 over here and put it in as 5/5. Now the way I determine what fraction it is I look at the denominator down here and I say I need fifths. So any number over itself is equal to 1. So I put in 5/5. That's my 1 that I borrowed. Now I can subtract. 5 minus 1 is 4. And that's over my common denominator 5, and 3 minus 0, which is 3, and now I have my final answer. So that's subtracting with whole numbers. Now just briefly down here, we've covered all of these little topics throughout this chapter without stating them. I probably should have stated them at the beginning, but I think showing by example a lot of times works better. So any number a times 1. Any number times 1 is equal to a. Multiplication's identity element of a is a, and this is actually called the identity property. The next one we have is division by 1. If I take any number and I divide it by 1, I get a. Well, this is really just a restatement of this one up here. And finally, any number divided by itself equals 1. And you'll realize that we've seen all of these different properties throughout our use in this chapter. So that concludes the material for section 2.2. I do have some supplementary material for you, but I won't cover it until the next lecture.